In this video, we're going to start talking about zeros of polynomial functions. But let's talk about some other terminology first. A complex number is a number written in the form of a plus bi, where a is the real part and b is the imaginary part, and I is equal to the square root of -1. 3 minus 2i is a complex number where 3 is the real part and -2 is the imaginary part. So, is 4 a complex number? Well, let's write 4 equal to, well, that's 4 plus 0i. Well, 4 is the real part and 0 is the imaginary part. So yes, 4 is a complex number. So we can do that in general and say that all real numbers are complex numbers. All right, let's go to the fundamental theorem of algebra then. Every polynomial p of x of degree x greater than 0 has at least one 0 in the complex number system. Again, all real numbers are complex numbers. So that's why this theorem works here. So the factor theorem tells me if p of a is equal to 0, then x minus a is a factor of p of x. If x minus a is a factor of p of x, then p of a is equal to 0. All right, so now I want to be able to determine if x minus 3 and x plus 2 are factors of this polynomial. Let's start with x minus 3. Now, since I want to know if they're factors, you know we're going to have to divide here. So you have two options. You either do long or synthetic division. Well, I'm going to choose to do synthetic division. So again, if it's x minus 3, I'm going to put 3 in the box. All right, so bring down the 1. And let's complete this. Because the remainder is 0, x minus 3 is a factor. So I can write this out. So now I want to check to see if x plus 2 is a factor of this polynomial. Now, if it is a factor of this, then I know it's going to be a factor of the original. And I want to make the polynomial function equation to be as small a degree as possible so that we can use other techniques later on. So let's check x plus 2. So that's -2. But remember, I'm going to use these numbers instead. Well, let's do this. So we do know that x plus 2 is a factor. All right, so what am I left with? Well, this is x squared minus 1. So p of x is equal to, well, we certainly know, let me go scroll back up, x minus 3 and x plus 2 times x squared minus 1. Now, I know we can factor x squared minus 1 using factoring techniques. I don't have to use long or synthetic division for this. We're done here. Now, you can tell very, very quickly what the zeros would be for this. If you have x minus 3, you know the 0 is 3. If it's x plus 2, the 0 is -2. If the factor is x minus 1, then the 0 is 1. And if the factor is x plus 1, the 0 is -1. Okay, let's do one other example with this. Now I want to determine if x plus 1 and x minus 7 are factors of this polynomial function equation. All right, so I'm going to start with x minus 7 first. So again, if it's x minus 7, it's 7 that goes in the box. Okay, put in the values. All right, so let's do the synthetic division for this. So the remainder here is 176 and not 0, so x minus 7 is not a factor. Now let's check x plus 1. So again, -1. Now I have to go back to the original values. Okay, so let's do this. Because my remainder is 0, x plus 1 is a factor. Okay. Now, how do I write this? Well, that's 2x squared minus 13x plus 15. Okay. So then the question is going to be, can I factor this any further? Well, I can break this down as 2x and x, and it looks like -3 and -5 are going to work here. So I can finish this then and write p of x is equal to, well, x plus 1 times 2x minus 3 and x minus 5. Again, now I should be able to tell what the zeros are very, very quickly when I ask for this later on. All right, so far we have been given possible factors. The goal is to find the factors ourselves. Okay? So I want to take a look at two equations here. X squared minus 9 is equal to 0, and x squared plus 6x plus 9 is equal to 0. How many unique solutions does each have? Well, you can tell the factoring for both, okay, and the number of solutions. Both of them have two solutions, but the x squared minus 9 has two unique solutions, while the x squared plus 6x plus 9 does have two solutions, but they're not unique. -3 has a multiplicity of 2. Okay? But notice the degree for both is 2, and both of them contain two solutions, not necessarily unique. Okay? So a polynomial function cannot have more real zeros than its degree. Okay? A polynomial function cannot have more real zeros than its degree. And that's exactly what the n0 theorem is saying here. But you can have n zeros, but they're not necessarily distinct. So for instance, if I have x cubed plus 16x is equal to 0, well, the degree of that equation is 3, so the most solutions or zeros I'm going to have is 3. But again, I don't know if they're going to be unique or not. I wouldn't know that until I solve them. Okay? So again, this tells me the maximum number of solutions, but we still do not have a way to find these as such. One other concept we're going to talk about in this video is what is called the complex conjugate zero theorem. So p of x has a real coefficient and a plus bi is a zero of the polynomial function, and its conjugate is also a 0. So now let's use this idea to be able to factor this polynomial function equation completely. Now, notice here 3i is a 0. So I'm going to write 3i. Now, its conjugate is also going to be a 0. So that's going to be -3i. Now, I can certainly write these as factors, right? X minus 3i. And this would be x minus a -3i, which is x plus 3i. Okay? Now, I can't use synthetic division easily with either 3i or -3i, but I can certainly multiply these two factors together. Notice it's the product of a sum and a difference, so that's x squared minus 9i squared. Remember, I squared is -1, so this is really x squared plus 9. So x squared plus 9 is a factor also of this polynomial function equation. So now I will use that x squared minus 9 and divide it into the polynomial. I will rewrite x squared plus 9 as x squared plus 0x plus 9. Okay, so what do I multiply x squared by to get x to the 4th? That is x squared. So multiply, that's x to the 4th plus 0x cubed plus 9x squared. Subtract, and that gives me -x cubed minus 2x squared. Bring down the next term, minus 9x. So what do I multiply x squared by to get negative x cubed? Well, that's a negative x. So take negative x times x squared, that's negative x cubed. Negative x times 0x is negative 0x squared. And negative x times 9 is negative 9x. Subtract. So that leaves me with negative 2x squared. This leaves me with a plus 0x. And I'll bring down my last term, which is negative 18. So what do I multiply x squared by to get negative 2x squared? And that's going to be negative 2. So multiply negative 2 times x squared is negative 2x squared. I'm going to move it down slightly. Negative 2 times 0, that's negative 0x. And negative 2 times 9 is negative 18. And that is 0. So p of x, you have some options here. Okay. I'm going to write it first as x squared plus 9 and x squared minus x minus 2. Okay. Now, you can certainly factor that trinomial. That'll be x minus 2 times x plus 1. Now, you have the option from here. Oh, change that to a plus. You can either leave it as x squared plus 9, or we can change it to x plus 3i, x minus 3i. And then write out the other two factors. I would accept either one of these answers for this.